Tell us where you're where you're joining us from. So I'm in London. Alexi, Amsterdam,
Yeah, as usual.
Dallas. Michael's in Dallas. LA Jerry. Who else have we got? Let's have a look. Where's the
South
list?
Korea, nice. Lisbon.
Oh, nice.
I
Got
hope
Lisbon,
I hope there
Turkey,
is
Washington State, South Korea. Okay, we're covering a lot of the globe so far.
I hope there is a nice weather in Lisbon. It should be, right?
Germany, Robert. Hi, Robert. If you want a YouTube link for later, here it is. This is streaming on there as well. So we'll give everyone a couple of minutes to join, and then we can get started.
What is the weather today in London?
In London, let's have a look. Very, very grey. So that's could describe any month of the year, though.
I don't know. It's probably only Amsterdam has not so. I would
I
like
think
quite specific weather.
it's 12 degrees. It's not that cold. 1 a.m. in Korea. Wow, this is good commitment to the ClickHouse call in the middle of the night.
I see many usual names, many familiar names. Welcome Arno, welcome Bruno, Derek, Eugenio, welcome George, Habibullah, Jerry, welcome Michael, Ramazan Palat. It's always nice to see you on every call. Welcome Robert Schulze. Thanks for the features. Welcome Sergey, Stuart, Todd, Yudi, Valery. We'll start in about now.
Now, let's do it.
Let's start. So this is ClickHouse release 25.10. ClickHouse Halloween release. We will spend most of the time for new features because we have a lot of new features. So many new features, so many performance optimizations, and more than 100 bug fixes. So let's start with something small and nice. And the first small and nice feature is the possibility to define aliases for tables. It is implemented as a new table engine. So you can create a table. You don't have to specify the structure. You don't need to specify the structure. And as an engine, you specify alias and the name of the source table, or the name of the source database and the source table. And this new table will just reference the existing table. And you can do any operations like insertions, selects, alters, even only if you do drop or detach or rename, it will just rename the alias, not the source table. All other operations will be just forwarded, proxied to the original table. Why do we need this? For migrations in your scripts, if you have to switch the script between two different tables, it is nice when you can just define an alias and it will be transparent to all the applications. What else? A new operator. The new operator looks like this, like a star shape. It can be written as this combination of characters, or in a long form, it will be is not distinct from. What does it do? It is similar to the equality comparison, and if you do just an equality comparison, it will compare nulls like not equal to each other. So null is not equal to null. If you write if null is not equal to null, it will also be false. Null is not less than null, not greater than null, not greater or equals, not less or equals. So nulls are totally incomparable, except with this new operator. This new operator will treat nulls as equal. Previously, in previous versions, this operator was also available, but only inside join on section. Now you can use it everywhere inside any type of statement. What else? A new function named conf. This function will just convert a number with its string representation from one base to another base. So in this example, we are converting number 111 from base 10, so decimal, to base 8, so octal. We don't have a dedicated function to convert into octal and back, so this is quite useful. I don't know why do you need octal numbers. Maybe you need like nonal numbers, or how to say base 9 numbers, or base 7 numbers. It will probably some sort of septadecimal. No, it is something else. Okay, so now we have this function, and actually we have it for compatibility with MySQL. We already had functions hex and unhex for hexadecimal and bin unbin for binary. But now you can use any sort of bases, even like base 36, which will use all the digits and also all the English letters. And yet another nice feature, support for limit by all. Let me explain what it is, because not everyone knows that ClickHouse has a special clause limit by, which does not exist in any other database, only in ClickHouse. Limit by is an extension to distinct operator. With the distinct operator, you can simply remove duplicates. But with limit by, you can specify something like limit 5 by country, or by several fields like country, city. And it will take only the first 5 records for each country, for each distinct country. You can even combine it with usual limit. So limit by is a separate clause, separate to limit. So you can do something like limit 5 by country and then limit 100. Now you can also specify limit 5 or any other number, limit 5 by all. It will just take up to 5 duplicate records that are duplicated by all fields. Nothing particularly interesting, but it is consistent with order by all or group by all. So let's take a look what else do we have. Column statistics by default. We introduced column statistics just 1 or 2 releases ago. But back then, you had to specify statistics for every column separately. Now you can specify statistics on a table level. Create table settings, auto statistics types, and you specify which types of statistics you want to create. If you want like everything that we have, you will specify min max, unique, and count min. Probably we will add more statistics in the future, but now we have these 3 types. Or you can do even more. You can modify the global server configuration with the configuration file and specify that now every merge tree table should have automatic statistics for all the columns. And these statistics could be used for automatic join reordering that we introduced in the previous version 25.9. And a few system queries. A new system query, system reconnect zookeeper. I would prefer to say that you don't need this query in regular circumstances. But sometimes you need it. When you have a lot of ClickHouse servers and a keeper cluster. And you notice that sometimes the distribution of connections between ClickHouse and keeper nodes is uneven or suboptimal. Like most of the servers, for some reason, connected to a keeper that is located in a different availability zone or in a different data center if you have multi-region setups. And you want something easy to just rebalance these connections. And with the new system reconnect zookeeper query, it will just reinitialize the session, supposedly connecting to a better keeper node. And another new query, a new mode for alter table. Now you can ask to rewrite data parts. Like in this example, alter table hits, rewrite parts. Or you can specify a particular partition to rewrite parts only in that partition. And it will do literally this. It will just read the existing data parts and write new data parts without merging them. It will be the same set of data parts, just written once again. Why do we need it? The first use case is when you use full disk encryption. In ClickHouse, you can configure encryption for your tables on a disk level, and it is independent on like physical or low-level encryption. For example, in AWS, you can ask for EBS volume to be encrypted, and they are even encrypted by default if you don't change anything. But sometimes you need more. You want to encrypt data on top of that. So if someone will access this volume, they will still not be able to read this data. And we use this option in ClickHouse Cloud for our customers. And it even supports rotation of encryption keys. So you can create a new key and specify it in the configuration file, and it will be used for the new data parts. And then you might need to rewrite data parts. So even for old data, ClickHouse will use new encryption keys. This is just one use case, quite narrow. Another use case is to apply changes when you try different physical layouts of the data, different settings, like a different compression block size. So to make these experiments easy, now we have this option, rewrite data parts. Before that, you could use optimized query, but optimized query is much heavier because it will do merges at the same time. Now about performance improvements. And we have so many performance improvements that I would like to say that this new release, 25.10, is all about performance. Let's take a look. And the first one is particularly interesting. A new physical layout for the string data type. How to explain? In previous versions, when you have a string column and you take a look how is it stored inside the binary file. The binary file is compressed, But you can actually decompress it with the ClickHouse compressor tool. And then if you look inside, you will see that every string is stored like the size and then the bytes of the string. Then the size of the next string and the corresponding bytes. And so on and so on. In the new layout, actually you have two different files. Column.bin and column.size.bin. And the first one will store only the bytes and the second only the sizes. And actually it is entirely identical to the format that we have for arrays. Arrays are already stored in this form. Sizes separate, data values separate. Now we found that it also makes sense for string. Let's take a look why. Let me try to show you a demo, and I will just copy paste some queries as usual. Let me first run ClickHouse server on my machine. Here it is, ClickHouse server, my favorite. And now let me open ClickHouse client. I will type just chc. I like it. And now I have the latest version compiled. It is not even 25.10, it is even 25.11 with some new commits. And actually, I don't need ClickHouse client, I only need ClickHouse benchmark. And we will do, we have two tables. Actually, let me show you these tables. The first one is named hits. And it is just a regular table, about 100 of columns. You know this table. The second table is named hits2. And the difference in this table, I have two settings. The first setting enables custom serialization information, and the second selects the new serialization for strings. String serialization version equals to with size stream. And now let's compare the performance of a few queries. The first query will be quite simple. Let's count the number of records where URL is not empty. And when I do it from the first query, it is about 165 milliseconds median. 163. Now I will do it from the second table. And Mark, do you know what question I would like to ask you?
What's the what's the average time going to be?
Yeah. And also
I don't know. Let's say 0.1 instead of 0.16 on the 50 percentile.
Okay, but why not aim higher?
Higher. Yeah.
I mean
Okay.
lower.
I don't know. I don't really know how much faster it's going to be. I don't know. We could do. Jerry says 0.01. Alexander says 0.001. Let's see who's
Okay,
going to be closer.
let's take a look.
0.03. Stuart
Yeah,
wins.
okay.
Pretty good.
Mark, do you have any sort of gifts to send for the winners to the winners?
Yeah, I think we can. We'll ask Tyler. Yeah, we'll send you a
It,
message, Stuart, and we'll get you some.
it's Tyler, and indeed we do. So, Stuart, hit me up, Tyler at clickhouse.com, and we'll make sure that you get something special. Congratulations, mate.
Okay, but now we have another query and another question. So this query will not just calculate the number of records, it will select the earliest 10 non-empty search phrases. And here is the old table, and we have about 140 milliseconds. Now the new table. And it will be easier because you have at least a hint. Previous time it was 5 times faster. Now it also should be faster, but I'm not sure if 5 times. Now let's ask only Mark. What do you think?
Oh, how fast is this one going to be? Okay, let's say, oh, I don't know. Let's say 0.03 again.
Okay, interesting. Let's take a look.
This one is
It is faster, yeah, but it is like only 10 milliseconds faster. You know, this maybe 20 milliseconds. This time I'm a little bit disappointed. But anyway, it's a good optimization. We saved like 15 milliseconds. Okay, what else? Another optimization. Replicated columns. It is a new internal in-memory representation of columns that you will not see in any table definition. It is entirely internal to optimize your queries. What does it do? Let's suppose you do a join. It could be just inner join, left join, or even array join. And this join multiplies your data many times. Like you do something like in this example, we have a table hits with just 100 million of records. And if we join this table to a similar table or just by itself, on a condition like if the IP address matches, it will generate 40 billion records, 400 times more. Because oftentimes from a single IP address, we have maybe 10, maybe 100, maybe even 1,000 of hits. And when you do this join, it for every IP address, it will do something like a full product, full direct product, like a cross join. And the question is, do we spend memory for multiplying all this data? And do we have to spend memory and CPU for this operation? And the answer is we don't. In version 25.10, we introduced a new representation of columns that contains information on how it should be multiplied without actually multiplying it. So we can name it lazy columns replication. And to use it, just enable this setting. I think we will enable it by default in the next release. In this release, we just made it available. And let me again run some queries and ask you how fast they will be. So first I will do this query, self join of hits by IP address. And I will
so this
just,
is this is with no optimization, is it? This one?
yeah, the first one without optimization. It will just take all the URLs, calculate hashes, and summarize. Actually, it is just for calculating and ignoring, just for an example. Let's take a look. So it started, it is running, it is running. How long will it take? For some reason, it becomes slower.
You said is this the one gonna process 40 billion records, or is it less?
Yeah, 40 billion records, but what 40 billion records means for ClickHouse? It should be like an instant. But anyway, so far it processed only 100 million records, and I don't like it. It does not look as this query will ever finish. I'm not used to queries that run longer than a few seconds. I use ClickHouse every day, and queries must be fast. So let me interrupt it, and I will run it with a new setting. Here it is. And it should be faster. And we already know that the only possibility is infinite time faster. But what do you think about the actual timing?
So the difference here is it's going to lazily evaluate what the data, the URLs.
Yeah.
How long should it take? I don't know. 10 seconds? Is that too high?
Okay. 1, 2, 3, 4, 5, 6.
Ramazan says 4 seconds. Oh, 8
8
seconds.
seconds. Yeah,
Alexander wants to know how big is the server in CPU and RAM?
it is quite an old server, but it still has 64 CPU cores. But it has a slow memory, so maybe it does not count as a modern server. And actually, it's not a server, it's my desktop.
Is it right that it only processed 200 million rows?
The source number of records is 200 million, slightly less, because we read from the hits table twice. The generated number of records, we can calculate it easily. And just to make sure
we actually counted 40 billion things.
We don't do any cheating here, so yeah, 40 billion.
Oh, wow. Yeah. Yeah.
Okay.
That's a lot of hits.
We have more performance optimizations. The next one is about Bloom filters in joins. What does it do? Let's suppose again we do a join. We have one table at the left side, one table at the right side. And the most efficient algorithm, if we can use it, is hash join, or more precisely, parallel hash join. But the question is it possible to take the data from the right table, make sort of a small sketch out of this data, and then use this sketch while reading from the left table as a pre-where condition? If you know ClickHouse, you know what is pre-where, and you know that pre-where is particularly fast. Sometimes it is as fast as using indexes, while it is not an index, it is full scan. And now we can do it for joins. So the right table, if it is not big, if it is fairly small, it will be used as a filter for reading, almost like an index, but not quite. Again, let me show it in a demo. And here I will connect to another server. Oh, I am already connected. And on this server, I have a database named TPCH stats. It contains data for the TPCH benchmark. And I will compare the performance of just a single query without runtime filters, like a baseline performance. It is fast. Maybe we did not have to optimize anything. It is just 150 milliseconds. Okay, but now let's change and enable runtime filters. And again, let me ask you, how fast will it be?
All right, come on, Ramazan. Now, Ramazan, Stuart, Alex, Jerry, what are we saying? Okay, so 0.16. Alex is saying 0.04. Stefan is saying 0.03. Stuart's saying 0.08. Okay, I'll say 0.1. And Jerry says 0.05. Omar thinks it's going to get slower at 0.72. Oh no, 0.072. Okay, I think we've got every possible number smaller than that covered now.
Yeah,
What about you? What are you gonna do? Or do you know the answer already?
yeah, I know the answer,
Uh,
but I forgot it.
Harrison says 0.06, so we really have got everything covered. Here we go.
Okay, our audience cannot lose.
Come on, ClickHouse. 0.01, 0.1,
So
0.07. Who said
the
0.07?
sustained performance is 0.07.
So Omar's the winner.
Congratulations.
Yeah, so Omar, send Tyler a message and he'll give you something.
So it is
Nice work.
more than two times performance improvement thanks to the construction of Bloom filters and using them inside preware. Okay, but we have more performance optimizations. And this one is also about joins. Maybe some people should ask when we will stop optimize joins, but actually we will never stop. This is about push down, condition push down for complex conditions that cannot be pushed down as is. Let's suppose we have inner join with two tables, and the condition is a combination of two conditions with or with disjunction, and each of them has one condition on one table and another condition on another table. And if we just rearrange this logical expression, we cannot simply create a condition that will cover this. But what we need is to generate a condition that probably less selective, probably more general, but still filter the records that will contain the records matching this condition. So in this case, we will generate a condition like n1 name equals to France or n1 name equals to Germany, and the same for n2. And then we will push down. So it's not complex. It is quite obvious how it works. And all you need is just to enable this setting. And again, we will probably enable it by default in the next release. What else? And another optimization possibility for secondary indexes. Now you can control when the secondary indexes will be calculated. Until recently, secondary indexes were calculated on insert. You insert the data and immediately this data is indexed. But in fact, ClickHouse has support for the case when certain data parts have a certain index and other data parts don't have the index. It will just use the index where it exists, and it will do full scan for data parts where it does not exist. So now we provide an option to postpone calculation of indexes from the insert stage to the merge stage. You enable the setting, exclude materialization of skip indexes on insert, and it will do what you want. Why it might even be needed. So let's suppose you create a quite heavy secondary index, like an index for vector search, HNSW. It could be quite heavy for calculation. Or you create a text index. Actually, text indexes are really lightweight. They work great. You don't have to postpone them. But maybe you want to make your inserts a little bit faster. Or maybe you use a service in ClickHouse Cloud when you have a small subservice for inserts and another large subservice that will do merges, background merges. And then it could be very reasonable to postpone materialization of the skip indexes. Also, you can disable materialization even on merges. In this case, you can manually do optimize table, manually do something like alter table, materialize index, whenever you want. You will have full control on that. And you can even exclude certain indexes from materialization by a list. Okay, quite a nice feature, but only for advanced users. Now about something unusual, something interesting. And the first one is the possibility to use negative limit and offset in your queries. Like in this example, select from logs order by time limit minus 100. What does it mean? It means take the last 100 records ordered by time. So the latest 100 records. But output them in a usual order. So ordered by time. It is especially useful for log navigation. In previous versions, you can achieve the same effect by ordering first in descending order to select the last 100 records, and then ordering again with ascending order. But to be honest, I did not like writing these queries, so I requested this new feature, and I really like it. And thanks to Nihal, who was an external contributor, but now he joined ClickHouse Inc. He is our colleague. He implemented this feature, and I'm really happy about this new possibility in ClickHouse. You can even use pagination with negative limit, like take the second page from the last by time. And this new feature, which is an experimental feature, is especially interesting. A new data type named QBit. QBit sounds very smart. It's something about quantum physics, but actually it means something else. Let me ask you, it's an abbreviation, but abbreviation of what exactly? Mark, let's collect answers from the chat and let you also try to guess if you don't know already.
No, I don't know. Let's ask the chat. So Stefan says, is this the Google vector format?
No, it's not from Google. It's probably our invention, but most likely someone already invented it.
Double invented it.
What?
Two people invented it at the same time.
I don't. It's a trivial feature actually, but very interesting. What does it mean qubit? What does it mean Q? Because bit we already know.
So Q is what? Quantized then, says Tyler.
Exactly, yeah, quantized bits. It's a new data type for vector embeddings to store vector representations of whatever you like, texts, images, videos from any LLM provider, any AI provider. And it allows you to tune the precision at runtime. So when you store vectors, you don't lose any precision. no information is lost. But when you query, you can ask to query faster. Let's take a look how to use it. So to use it, you just specify this data type, you specify the type of dimensions. It could be something like float 32, float 64, or bfloat 16, and the number of dimensions. So in this case, it is QBit with 1536 dimensions, each of them containing a value of type bfloat 16. And during select queries, you can calculate the distance with a specific function, L2 distance transposed. You specify two vectors and also the precision that you would like to take when comparing these vectors. The precision in the number of bits. In this case, it is just 10 bits. So it was 16 bits, but we are asking only for 10 bits for our calculation. And what will it do? It works in the following way. It takes the vector, it takes binary representations of every value in every dimension and takes every bit, every most significant bit, every second most significant bit, third most significant bit, and it combines the first bit of every dimension into like this bit vector, the second bit of every dimension into a second bit vector, and they store every bit vectors as a separate subcolumn. So you can efficiently read only the first bit of every dimension, or the first 2 bits, or the first 10 bits, most significant 10 bits. And then you don't pay for input-output, you don't pay for sending this data, receiving this data over network, you don't pay for decompressing this data, you will read only the number of bits you requested. And the distance calculation will be approximate, and the precision will depend on the number of bits you requested. So you can ask, like, calculate this faster, I don't care about the most precision, or like use the full information, I care about like saving all the original data. Let's take a look with one example. So in this example, we have a table named dbpedia. It contains 1 million of vectors with also 1,500 of dimensions. And the dataset can be downloaded from Hugging Face in just a few minutes, but I will not do it now. I already have it on my machine. And in this table, we have the original vector just for an example. And we will add the column with QBit data type, a new column. And let's compare the performance. So here is my machine, and we have ClickHouse client. Let me see. This table, yeah, it already has this new QBit data type. And to check it, let me copy paste one query. So what does this query do? It selects a few concepts like moon, Apollo 11, space shuttle, astronaut, rocket, and it takes a vector representation of these concepts using these subqueries. And we will find vectors and articles that are closest to these concepts. So something that is closest to astronaut, something that is closest to space shuttle. Take 1,000 of these articles, filter the articles that are identical to these target articles, and find something with 3 or more concepts. Okay, let's just run it. It is quite fast, 5 gigabytes per second, but it took 6 seconds. 6 seconds is okay, but it is not for interactive queries. Now let's use the new data type, QBit. And the query will be almost identical. The difference is that now instead of vector, I use QBit column, and instead of L2 distance, I use L2 distance transposed. And in this example, I will request just 5 bits, not 32, but 5. Okay, it is much faster, 1.7 seconds. It is actually really great. And you know, in this case, it works from the local file system. If I used a network file system or AWS S3, the difference will be even bigger. But what about the results? Apparently, they look relevant. Space capsule, space flight, orbital space flight. Yeah. Let's compare the results to the previous one. Here is the previous result, Apollo program, Apollo 8. They are different, but still relevant. I think it is successful. Interesting if I will use something like 10 bits. Sorry if it will take.
So with 10, we're saying the results should be more like the kind of brute force.
Yeah, it should
Okay.
be almost identical to the original result. Let me just replace it here in my text file. It will be faster. Because, you know, for some reason, I'm interested checking it right now.
So how long will this take? Maybe twice as long, or?
3 seconds, actually almost
Oh, yeah,
4
okay.
seconds.
A little bit more. Not too bad.
And actually the results are identical to the brute force. We have Apollo program, Apollo 8, spaceflight, Skylab. Yeah, I see. So now we have the same results, but at least 1.5 times faster.
How do you think people would normally use the varying precision? Would you be likely using different values for different queries?
I think most of the queries will use the
Okay.
same precision, and I think it will be around like 9 or 10 bits, maybe even 8 bits. But for some cases, for ad hoc queries, you can do something like validation, like ground truth check, and it makes sense because you don't have to store the original vectors and quantized vectors. You only store this bit sliced representation, and you get both of the cases for free.
Yeah. Stefan is asking whether you could use something like this as like a rough pre-filter on your data.
Yeah, it is entirely possible. You can do like a subquery with 1,000 of candidates, and inside this 1,000 of candidates, you query again your table, but now filter by more precise, more
Oh,
precise.
interesting. So you do like the least precise to get a bunch of records to work with, and then you order them more accurately.
Yeah, but just in case,
Yeah.
for this, you will probably use HNSW index that we already have. It is production ready since previous version 25.9, and it already supports rescoring, and rescoring is exactly what we just described.
Stefan
Okay,
says this will speed up his query significantly. Cool. You'll have to let us know how fast they get, Stefan, once you give it a try.
yeah, really interesting. I would like to hear more feedback about this feature because it is very fresh, very new. Interesting to see the numbers from your production. Okay, now about data lakes. Every release we have something about data lakes. And in this release we have something very unusual. Apache Pymon. What is Apache Pymon? It is a data format like Iceberg, Delta Lake, Hudi, but it is Pymon. What does it mean? I don't know. Anyway, it is another data lake format, now fourth, and someone uses it and someone needs it in ClickHouse. So now we have it in ClickHouse. And you can use it as easy as select star from table function Pymon. It supports Pymon on S3, GCS, Azure, even local file system. And it is also experimental, so interesting to see, interesting to learn from your experience. What else about data lakes? A few improvements like optimization for using the table order when you query data lake with select with order by. Or a new system log table for Delta Lake metadata operations. Also useful if you want to know how exactly ClickHouse works with your Delta Lakes. And a few more things as a bonus. A new website named ClickGems. It is an analytics and reporting tool for Ruby gems. If you use Ruby, I don't, but who knows? We already had a similar website for Python, which is named ClickPy. But now we have it for Ruby. And if you don't like Python, if you like Ruby, you will find this website interesting to monitor your package downloads, to look at trending packages, to compare different packages. clickgems.clickhouse.com. Interesting why this website is yellow. It should be red, I think. And another announcement. House Party, the sequel, featuring the Chainsmokers. So Chainsmokers is kind of a popular musical collective. We selected Chainsmokers to represent ClickHouse because their name starts with CH. And now it is a second event, House Party. It will happen in Las Vegas, December 2nd. So please register if you want to participate in the party.
Will they get to meet you if they come to the party?
Yeah, sure, I will be in the party, not as a headliner, but I will be there.
No singing by you.
Who knows? Maybe you will get me to do it. but you will have to ask ask really nicely. Meetups. The next meetup, actually, it happened today. So if you are not in Tallinn, Estonia today, it is already late for you. But then you can visit our next meetup in Stockholm or in Bogota. I will be on some of these meetups, but not on all of them. If you are in Australia, visit Laracon about Laravel. If you are in South Korea, there will be ClickHouse Dev Korea Seoul. There will be another meetup in Cyprus, and finally house party in December. And we have a lot of interesting stuff in our blog. If you want to learn how QBit is implemented, how it works, we have a write-up about it. We also made the JSON data type many times faster. We achieved 170 times compression of logs. We tested 12 different frameworks for building agents with ClickHouse and selected the best. I will not tell you which framework is the best because you have to read this article. If you are interested about ClickHouse native observability product ClickStack, and if you are interested about AI agents, now you can trace agents with ClickStack. And a lot of customer stories from Netflix, GitHub, and Laravel. And just a little bit more. So this is the announcement about the conference that is that you are also late if you did not visit open house in New York City. But why I am presenting this announcement right now? Because now we have all the videos from this conference published on YouTube. Just type something like Open House Roadshow or Open House New York or Open House ClickHouse, and you will find a lot of interesting videos, keynotes from ClickHouse engineers, customer stories from like one of the largest banks in the world who is using ClickHouse. Don't miss these videos. And now we have a few minutes for your questions.
Cool. Let's let's do some questions. And I guess, yeah, Tyler also wanted to say the videos from Amsterdam will be there soon. I think you did, was that a couple of days ago you did that?
Yeah, just 2 days ago, yeah. It was open house in Amsterdam. And if you did not visit it, you are also late. Sorry.
Need to go back in time. Okay, here's the questions. First question. Do you have any plans or timeline for when ClickHouse will fully support all Iceberg features like Trino? Now, I thought it already did, but maybe you know better than me.
If we look at the compatibility features, like specific metadata information inside Iceberg, things that allows to do partition pruning, to use indexes inside the files, to use table order, schema evolution. We have all of this. So if you know about a particular feature that we did not yet have, it could be about compatibility or about performance. Tell us and we will implement it. And most likely we already implemented it or we are working on it right now. I would say Iceberg is like 99% complete. A few more things about performance, but about compatibility, it is pretty solid.
Cool. I think it's also Our colleague Tom wrote a blog post showing how to use it if you're using ClickHouse Cloud. So I've posted that link. Okay, next question. Any plans to implement I don't know if this is like SCANN for vector search. Is it scan? It says HNSW seems like a bad fit for high write throughput. Robert has then replied, it's tempting to implement. If you want to hack it, we are open for PRs.
Yeah, it's very interesting. The difference is that HNSW requires a lot of memory, and the amount of memory that is required is comparable to the original vector sizes. So in many cases, you have to scale your machine to a large size or even scale horizontally. It depends on the data volume. If you have hundreds of billions of vectors, sometimes HNSW becomes non-practical, and we are actually interested in implementation of scan. It will be probably one of the next steps, not like the very next step, but one of the next, probably next year. Cannot promise, but it's really interesting.
Ooh, okay, next one. Does Kafka Engine V2 support the exactly once feature? That's the first part of the question. And then this is Stuart says the performance of the Kafka Engine's producer isn't very good. Are there any plans to work on that?
About the exactly once semantic. Yes. The new version of Kafka Engine, Kafka 2, was developed specifically for this reason, to make the consumption and the commit in ClickHouse atomic and consistent with respect to retries, regardless of what happens inside Kafka, regardless if Kafka decided to do partition rebalance, or if the number of partitions changed. The new engine Kafka 2 tracks the offsets for each partition reliably in ClickHouse Keeper. So this is the main advantage. The old Kafka engine supports at least once, so it allows duplicates in certain circumstances. And about the performance of Kafka Broker, interesting, it depends on configurations. It should be scalable by the number of workers, and again, it depends on the number of partitions, and it could work even in a distributed fashion on many replicas. Sometimes it depends not only on ClickHouse, but also on Kafka. So sometimes ClickHouse is ready to take all the data, but Kafka just cannot output this data with the required performance. But sometimes there could be a CPU bottleneck on the ClickHouse side. It requires profiling.
Cool. Okay, another one. Okay, so follow up to the iceberg question. So Tuan Tran says, I tried to use the iceberg catalog to do inserts and that didn't work. Now I know that inserts work right now if you use the iceberg table engine. Do you know if it works through the catalog as well, or is it only through the table engine?
That's interesting because as far as I remember, we had this implementation already, insertion through catalogs.
Okay.
But I'm not sure which version has it. Yeah,
But hopefully if you took 25.10, it might already be there. So maybe we need to make an example showing how to do that.
Yeah, that's interesting. It will require clarifications.
Cool, then there's another one saying, is there a plan to have a setting that will enable all the optimization settings? It feels like the setting statement is longer than the SQL itself. I mean, I think like the general idea is when the optimization is introduced, it's it's turned off and you have to turn it on, and then eventually they all get on by default, right? Like a few versions later.
Yeah, it's just a sort of a conservative approach. We don't enable all the new optimizations immediately. First, we made them available. Sometimes it's not a problem to enable optimizations in the same release, but certain optimizations can change the data format, like that optimization for strings. And that means if it is enabled, you cannot downgrade. So we keep a buffer of one or a few versions that already support this format, but did not enable it by default. And then when we enable it by default, you can downgrade to any of these versions safely.
Cool. And then we got one more. So are there any plans to make select queries faster for the JSON data type? Of course, they're already fast. I'm just wondering if they'll be faster. That's Stuart as well.
We always want to make queries faster. Not only select queries, not only select queries on JSON. And we did it recently. Recently, in the previous release, we introduced a new format for dynamic data path. And
I
it
think
is
Pavel wrote a blog about it, right?
yeah, we have an article about this, but who knows, maybe we have a lot of potential still uncovered. Anyway, today ClickHouse is the fastest database on JSON, with no one even anywhere close to ClickHouse. It's not about like several percent or tens of percent difference. It's about multiple times difference to the closest competitor. And the closest competitor is not a database that many people know. And if you compare to databases like MongoDB or DuckDB or Postgres, it will be 100 times difference.
I think we've exhausted all our questions, so I guess we can probably, we're a little bit over already, but we can probably wrap that up, I reckon. So thanks everybody for joining.
Okay, thanks
And I
for
guess
listening.
we see everybody at the end of November.
Happy Halloween.
Yeah, children are going to be wanting to go out tomorrow. Cool. See you all next month. Thanks for joining.
See you
Bye.
next time.